Hello students, welcome to Physics Pathshala. Today we'll have chapter 2, class 11, chapter 2 units and measurement error analysis. Class 1. Error analysis. This error is linked to measurement of any quantity, or here we say physical quantity in physics. As we have discussed already, physical quantity is the quantity that will be very useful or you will be using to express mathematical equations for laws of physics. To understand physical world and its happening or activities or phenomena, we have found out different laws. To express those laws in mathematical form, we will be using physical quantity. And this physical quantity should be measurable. We should be able to measure it, and it is known while measuring any physical quantity using any measuring instrument, we will have certain error. That means while measuring, the measured value should be equal to the true value or exact value of the quantity, whereas we find some deviation between measured value and exact value of the quantity. This is true value or exact value, whereas this is measured value, that is the value we got after measurement using any measuring instrument. Due to this deviation or inequality, due to this deviation or inequality between measured value and true value, error is generated. That means we want to measure any quantity, we should get its true value, whereas we don't get. That means we get less or more. That is some different, and the difference is error. Difference means difference of true value and measured value. The difference is the error we come across. Suppose until unless we know the error and will consider and resolve it, we cannot reach or we cannot get our job done correctly. It's suppose we have one basket. We want to carry certain items within that. If you do not know exactly the dimension of each item and dimension of the basket, then in that case, sometimes this these items will be bigger to this basket, and we cannot keep all those items which we want to carry. And in other cases, suppose we are going to purchase certain items from a shop, we have, as per price, we have paid one for 1 kg of that item, but due to error in measurement, we got less than that, 950 grams, but we have paid for 1 kg. That is the difference or error we come across in every measurement. Suppose another example is, we have something, some pipe, to find out its length exactly, and we have 1 meter scale with us, meter scale, and that meter scale is graduated in centimeters. That means up to, and each centimeter is again divided into 10 millimeters. 10. We, if the length of that 5 is something else in bit and comes in between two lines of this division, that is, one division is 1 millimeter, that either you have to tell it is 8 millimeter or 9. Exactly we cannot find out, and there is the exact measurement, there is the difference between this true value and measured value. This is the error. And in other cases also, if number of times we will do take the measurement, in different measurements we will get different types of different values of error. To conclude what is the exact error associated with that measurement, what we will do, we will take a number of measurements, and the arithmetic mean of that measurement will be taken as or assumed as the true value of that item, or that will be assumed true value. And in each measurement we'll be finding out, suppose this became assumed true value is arithmetic mean, true value minus measured value, that is the error for that measurement. In similar way, for second measurement, error will be assume true value minus measured value. In another case, same, that the difference between assumed true value and measured value will give the error for each measurement. Now it is clear that each measurement is associated with certain error. Summarizing, we can conclude that every measurement is an approximate value. It is not the exact value due to existence of error in measurements. This error happens approximate due to error in measurement. This error can be of two types if it is known or fixed type. It is systematic error. Systematic error. It may happen due to instrument problem, which is already known to us. That means the error which is already known type error, it is systematic error, and it is known mean we can do the remedy of it or we can resolve it. You once we know that due to the instrument always it gives some extra, that one can be deducted in our final measurement. That is fixed type or known type error. It may be due to instrument or it may be due to person who is measuring, or it may be due to the process or procedure or technique of measurement. So all these errors are termed as systematic error because it's known type error. Once it is known type, we can do its correction. Other type error is random error. This is unknown error or varying error. We do not know when it will be less, or this is known type or fixed type. It will be either in positive end or in negative end. Means it will give more than the measured value or less than measured value always. If the instrument gives less than, it will keep on giving less value. If any instrument is giving some more value, means it will keep on giving more value. But in random case, we do not know when it will give positive or negative. We do not know how much will be the magnitude. Also, magnitude also will vary. It will, where in this case magnitude will be fixed one, and that fixed value can be corrected. Here we do not know. We do not know magnitude. We do not know in which direction it will increase. It will give more value or less value. These type of value, these type of errors are termed as random error. And to find out exact value of error, we do a number of measurements. We do a number of measurements, and mean value will be very nearer to the exact value. Mean value will be very nearer to true value, or it will be termed as assumed true value. This is mean or a mean. A number of measurements are being done. That means suppose A1, A2, A3, we get the measured values. In first measurement, we got our measured value is A1. In second one, A2 and A3. Mean or average value of these measurements is A1 plus A2 plus A3, and number of measurement is 3. It is 3. If n number of measurements will be there, then it will be A1, A2, all up to n times by divided by n. In this case, n is 3, hence it is a1 plus a2 plus a3 by a3 is the am or value, mean measured value, or it is assumed true value. Now, let us find out what is the error associated or random errors associated with the measurement. Every measuring instrument will have error associated with its measurement. That means the measured value will not be equal to true value. Here two terms will be using. If measured value is if measured value is very nearer to true value, then we'll say that measuring instrument is accurate, or accuracy of that measuring instrument. Accuracy of that measuring instrument shows the measured value is how nearer to the true value. Another term we'll be using for measuring instrument is precision. Precision of any measuring instrument is what small division, what small quantity the instrument it can measure. Beyond that, it cannot measure. Like we have two filters. We have here big stones will drop, whereas it will be able to filter. The same stone which this filter cannot filter, this will be able to filter. That means this is the it has more precision, or it has more power, so that it can filter very small items, but the same small item cannot be filtered with this filter having big holes. Then precision, it is more precise. It is more precise, or precision of this filter is more. Same way, if you have two measuring instrument, the measuring instrument which can measure the smallest one is more precision. Beyond that, it cannot, beyond that, more than that small value, it cannot measure. Hence, precision is the smallest quantity that can be measured by an measuring instrument. Accuracy of a measuring instrument is how close the measured value will be to the true value, very nearer or close. Due to this precision of instrument, we come across some errors. This error will be told or termed as least count error, because the smallest quantity that can be measured will be the least count for that measuring instrument. For that measuring instrument, least count is the smallest quantity that can be measured by the measuring instrument. By the measuring instrument. This is list count, and the error which we come across if the quantity is smaller than list count, then some error will be there. We cannot measure the exact one, and that error will turn the list count. And this is termed as precision of the instrument is limit is up to list count. Now we have random errors. With us, we can express this random error in three different ways. One is using mean absolute error, percentage relative error, or fractional error. Third is percentage error or percentage error. One is absolute error, mean absolute error. Second one is relative error or fractional error. Third one is percentage error. We'll calculate how we can get this mean absolute error and relative error and percentage error. This is percentage error. This is relative or fractional error. This is absolute error, mean absolute error. In three different ways we can express a random error.